NASA researchers are creating a spot colder than the vacuum of space inside the International Space Station. In 2018, a new atomic refrigerator will blast off for the space station. It's called the Cold Atom Lab, or CAL, and it can refrigerate matter to 1/10 billionth of a degree above absolute zero, just above the point where all the thermal activity of atoms theoretically stops. At this temperature, atoms lose their energy and start to move very slowly, explains Rob Thompson, CAL project scientist at NASA's Jet Propulsion Laboratory, or JPL. At room temperature, atoms bounce off each other in all directions at a few hundred meters per second. But in CAL, they'll slow down a millionfold and condense into unique states of quantum matter. CAL is a multi-user facility that supports many investigators studying a broad range of topics. Eric Cornell, a physicist at the University of Colorado and the National Institute of Standards and Technology, will be leading one of the first CAL experiments. Cornell and his team will use CAL to investigate particle collisions and how particles interact with one another. Ultra-cold gases produced by the Cold Atom Lab can contain molecules with 3 atoms each, but which are 1,000 times bigger than a typical molecule. This results in a low-density, fluffy molecule that quickly falls apart unless it is kept extremely cold. How is particle behavior affected as more particles are introduced? What can be learned about quantum objects when several atoms are interacting at the same time? Cornell says the way atoms behave in this state gets very complex, surprising, and counterintuitive, and that's why we're doing this. Cornell shared the 2001 Nobel Prize in Physics for creating Bose-Einstein condensates, another state of quantum matter that can be studied inside CAL. Bose-Einstein condensates are essentially blobs of quantum matter that look and behave like waves that exist at these ultra-cold temperatures. In the free fall of space, the condensates can hold their wave-like forms for 5 to 10 seconds, much longer than on Earth, providing researchers a window into the quantum realm. Thompson says we can use CAL to test general relativity and quantum mechanics. One of the biggest questions in physics today is how those two work together. University of Rochester physicist Nick Bigelow and University of Berkeley scientist Holger Mueller, along with their colleagues, plan to use CAL to test a cornerstone of Einstein's theory of relativity, the equivalence principle, which holds that gravity and external acceleration cannot be distinguished experimentally. They plan to repeat Galileo's iconic experiment dropping cannonballs off the Leaning Tower of Pisa, but using atoms instead. Dropping atoms inside CAL and letting them fall for several seconds as the station orbits Earth will allow researchers to precisely figure out the differences between how the atoms accelerate. This experiment may reveal how gravity and spacetime are woven through the quantum realm. A researcher at JPL named Jason Williams also plans to use ultra-cold 2-atom molecules to develop tools for the next generation of precision gravity tests with quantum gases. Many more experiments are planned for this cool new laboratory, and no one knows where they will lead. With CAL, says Thompson, we're entering the unknown. For more from the International Space Station, visit www.nasa.gov/station. For cutting-edge physics on and around Earth, stay tuned to science.nasa.gov.